Look closely at the glowing green light on your smart meter. You have been told it represents progress. You have been told that being more efficient, using less to do more, is the key to saving the planet. It is a lie. In 2026, the greatest trick the system ever played was making you believe that a more efficient machine consumes less energy. The reality is far more terrifying. Every time we make a chip faster or an engine cleaner, we do not save a single drop of oil or a single watt of power. We simply make the destruction of our resources cheaper. The AI on your phone uses nearly 10 times more power than a standard search. That tiny request consumes 2.9 watt-hours of electricity. It feels weightless, it feels digital. But beneath the surface, it is a physical furnace. Welcome to the Jevons paradox. The more efficient we become, the faster we burn. Think again. To understand why efficiency failed us, we must travel back, before the cloud, before the silicon chip, to 1865, England. An economist named William Stanley Jevons was watching the skies of Manchester turn black. He was studying coal. In 1712, the world had the Newcomen engine, a clunky brute. It was terribly inefficient. It consumed vast oceans of coal just to keep the water pumped out of the mines. Then James Watt arrived. He created a miracle of engineering, a separate condenser. Watt's engine used far less coal to produce the same power. The logic of the day was simple. If the engines are more efficient, we will burn less coal. We will save money. We will save the resource. Jevons looked at the ledger books. The logic was wrong. He was a curious non-expert. He looked at the hard data. The numbers were clear. Jevons saw that total national coal consumption did not fall. It absolutely exploded. This wasn't a glitch, it was the birth of the machine. The efficient engine made coal incredibly cheap, and because it was cheap, it was now useful everywhere. Suddenly, every factory, every locomotive, every ship wanted one. Total coal use soared, not because the machines were wasteful, but precisely because they were economical. In his famous 1865 book, The Coal Question, Jevons realized the terrifying truth. Efficiency is the accelerant of growth. Here is the bar talk analogy. Imagine you replace an old, smoky open fireplace with a modern ceramic stove. Yes, it can heat the same room with half the wood. Or you realize you can now use the same amount of wood, but heat your 4 rooms instead of 1. That is the rebound. You don't save the wood, you maximize the comfort, and you consume more wood. The Jevons paradox was not a malfunction. It was the birth of the modern growth engine. We didn't learn. Look closely. Welcome to 2026. We didn't learn. We just changed the fuel. They call it the cloud. It feels abstract, weightless, clean. It is a lie. The cloud is someone else's computer, millions of them, stacked in a physical fortress that must be fed 24/7. The engine of this anomaly is the hardware. Every single joule of electricity consumed by these server racks is not recycled. It must be expelled. It is transformed into vast volumes of physical waste heat. Look closely at the data they hide. Here is the cold, wet reality. Making a system more efficient in the digital age just means making it devour energy faster. A single ChatGPT request consumes nearly 10 times the power of a standard Google search. 2.9 watt-hours for AI versus 0.3 for a search. It feels instant. It feels free. It adds up. But data centers do not just eat power, they drink. To keep the chips from self-termination, we use water, billions of liters. Analyzing hidden water consumption is a nightmare. The industry suffers from a lack of transparency. The shared sigh is necessary. Dealing with these invisible walls is exhausting. Look, this isn't abstract. Just processing 10 to 50 queries on GPT-3 can consume half a liter of fresh water. An average facility evaporates 2 million liters daily. That is the daily water consumption of a small town. We are trading local water aquifers for digital intelligence. It is not just about the source, it is about the physical path. The AI system is bound to rusty wires. Data centers require constant baseload power. If the local grid overloads or aquifers are depleted, the entire digital illusion halts. We pay for this. Look, this isn't just a line on a graph. In specific US regions, the electricity market costs to power these data centers translates to an $18 per month increase on your electric bill. This is not a fantasy. The architects of the system know the truth. Jensen Huang, CEO of NVIDIA, admits it. AI is energy, AI is chips, and we need more energy. Sam Altman, CEO of OpenAI, echoed this in Senate testimony. AI abundance is limited by energy abundance. He is right. So they build. In 2025, global capital expenditure on data centers surpassed spending on global oil supply. We are doubling down on the furnace. The shared sigh returns. Think about that for a second. They project global electricity consumption of data centers to reach 1,500 terawatt hours by 2030. That is the energy consumption of a major nation. Here is the bar talk analogy. If your car is twice as fuel efficient, you can save gas, or you can drive twice as much. The AI industry, trapped in this scaling law feedback loop, chooses the latter. Every efficiency gain simply enables larger models. Look closely. Bigger models demand bigger physical infrastructure, and we build. The loop is mathematical. The furnace expands. We built a system that consumes everything. AI abundance is limited by the abundance of energy. We know this, but how do we live with it? How do we sleep? Syntactic grit, we don't. We lie to ourselves. Think again. That green light is not a signal of safety. It is a psychological trigger, a biological hack designed to keep you from looking at the furnace. Psychologists call it moral licensing. The truth is, when the system allows you to make a small, green choice, it grants your brain a subconscious permit to be wasteful elsewhere. Consider the dieter's treat. You finish an exhausting workout, so you reward yourself with a calorie-dense meal. You undo the deficit. Efficiency works the exact same way on a global scale. We buy an electric vehicle or install LED bulbs, and we feel the shared sigh of relief. But that relief is a trap. It frees us to drive further, use more data, and consume more products that require massive energy to build. Look at the physical board. The threads holding this digital acceleration together are fragile. 99% of the global supply of refined gallium, a critical metal for next-generation efficient chips, is controlled by a single geopolitical actor. If this physical choke point closes, the AI revolution doesn't just slow down, it stops. We are trading our energy independence for an efficiency that we cannot even control. And why? Because the industry is trapped in a bigger is better scaling law. The Jevons paradox is now a feedback loop. Every time an algorithm becomes more efficient, the tech giants don't save power. They build a bigger model. This is perfectly legal, automated theft of our future. We are locked into a cycle of ever-increasing energy throughput. If the only check on growth is misery, then we will grow until we are miserable enough to stop. Look, we are tired. Dealing with these invisible walls is exhausting. The system mathematically exploits our hope. It tells us we can consume our way out of a consumption crisis. Jevons warned us in 1865. He said that the economical use of fuel is not equivalent to diminished consumption. The very contrary is the truth. We ignored him for 160 years. Now the bill is coming due, not in carbon credits, but in real physical constraints. Grid collapse, water scarcity, the erosion of human free will as we become biological servers for the AI furnace. They aren't just mining coal or silicon anymore. They are mining your psychology, using your green guilt to keep the machine running faster. The loop is closed. The furnace is hungry, and efficiency is the spoon. If efficiency is the spoon feeding the furnace, then it is time to break the spoon. The Jevons paradox is not a law of physics. It is a choice. Technologically, we can opt out. We are shifting from massive models to SLMS, small language models. These are specialized. They are lean. They cut the compute and energy requirements by 90%. We can implement defensible data deletion. We must stop the endless hoarding of digital waste. This isn't just about saving space. It's about starving the furnace of its fuel. The shared sigh is finally here. I know you are tired of being a biological server, but consider this. Growth is a habit, but sufficiency is a superpower. Economically, the fix is brutal but necessary. We need progressive energy pricing. We need absolute energy caps. We must prevent the cost of consumption from falling as efficiency rises. You are not a victim of the algorithm. You are the architect. When you choose specialized tools over massive ones, you reclaim your free will. Efficiency was the trap. Sufficiency is the escape hatch. Think for yourself before the machine does it for you.